Let's look at this example. A group of female managers has lodged a complaint with a personnel department. They feel that women tend to remain in low-level management positions when promotions are handed out. The personnel department has obtained data in which managers have been employed for at least 1 year. The data is summarized in the following contingency table. So you can see in total we have 960 male managers and 240 female managers. In total 1,200 managers, and from this side we have 324 managers who got promotion. The result is yes. And 876 managers who didn't got promotion. And here inside the table we have 288 male managers who got promotion, 672 male managers who didn't get promotion, 36 female managers who got promotion, and 204 female managers who didn't get a promotion. So if we define M as the event that manager is male and A as manager is promoted, now we are going to obtain these probabilities. Number 1, the probability that a manager is promoted. So promoted is yes. So in total we have 324 managers who are promoted divided by the total number of managers, NS is 1,200, so the probability is 27%. What is the probability of the manager? A manager is not promoted. So when 27% of managers are promoted, so it means 73% of managers are not promoted. So we can obtain these probabilities by using proposition 2. The probability of A prime is 1 minus the probability of A. So 1 minus 0.27 is 0.73. Or we can obtain it directly from the table. Who is not promoted, it means A prime, it means no. No promotion. So in total we have 876 managers who are not promoted divided by the number of people, managers in total 1,200. Again 73% of managers are not promoted. The probability that a manager is male, so we have 960 managers who are male divided by 1,200 managers in the department, so 80% of the managers are male. The probability that a manager is both male and promoted, again and both male and promoted, its intersection. So the intersection of male and promotion is yes, the intersection of M and A is this cell. But it's the number of the outcomes in intersection. We need the probability. So by dividing 288 by 1200, we can obtain the probability of the intersection. So male and promoted is 288 divided by NS. The number of outcomes in S, 1200. Given that keywords for conditional probability, given that the manager is male, the probability that he is promoted. So given that the manager is male, so is the conditional part. So the conditional part is M, or male. Manager is male. And the event that we want to obtain its probability is promotion. So the probability of getting promotion, given that the manager is male, the probability of A, given that manager is a male, the probability of getting promotion, given that the manager is male, is the intersection of A and M. We have it here. Divided by the probability of conditional part. The probability of conditional part is the probability of M, male. So the probability of male is 960 divided by 1200, and the probability of A intersection B, it means male and promotion, is male and yes, is 288 divided by 1200. So the probability is 0.3. Are these events A and M mutually exclusive or disjoint? So what was the definition of mutually exclusive or disjoint? It means the intersection of A and B should be empty. And according to proposition 1, we know that the probability of an empty event is 0. So the probability of the intersection A and M should be 0 if they are mutually exclusive. But you can see the probability of M intersection A is not 0. Even you can see that the number of events in A intersection M is not 0, it's 288. So A intersection M is not a null event. So the probability of A intersection M is not 0. So A and M are not mutually exclusive. Number 7. Calculate the probability that a female manager is promoted. So it's again a conditional probability, but you cannot see the keywords given that. So but if you read it again, you can see we have an information. We are going to calculate the probability of promotion given that the manager is female. Calculate the probability that a female manager is promoted. It means we know that that the manager is female, so we want to calculate the probability of the promotion. So it's the probability of getting promotion given that the manager is female. So M is male, so M prime is the complement of male is female. So M prime is female. According to the conditional probability formula, again, the probability of the intersection of A and M prime divided by the probability of conditional part. The conditional part is the probability of female. The probability of female or M prime is 240 divided by 1200, and the probability of promotion and female is 36 divided by 1200, so the result is 0.15. Number 8, calculate the probability that a female manager is not promoted. So again, it's the conditional probability. Again, in advance, we know that the manager is female, so we are going to calculate the probability of not getting promotion. So it's if promotion is A, not promoted is A prime, so the probability of A prime given that female is M prime. So the probability of A prime intersection M prime divided by the probability of conditional part, it means the probability of M prime. So it's A prime and M prime, female and no promotion is 204 divided by 1200, and the probability of M prime is it means the probability of female, we have in total 240 female, so the probability is 240 divided by 1200, and the result is 0.885. Again, we can obtain, you can see that in these two probabilities in 7 and 8, the conditional part is fixed. Here you have A, here A prime, so the probability of A prime given that female is 1 minus the probability of A given that female. So we can also obtain the results from proposition 2. So 1 minus 0.15 is 0.85. Number 9, investigate the probability of A intersection M prime is equal to probability of A prime union M prime. You remember that it's the De Morgan, one of the De Morgan's rules. So the probability of A intersection M prime according to the proposition 2 is the probability of 1 minus the probability of A intersection M. So AM 288 divided by 1200. So the probability is 1 minus 288 divided by 1200 is 0.76. But what is the probability of A prime union M prime according to the proposition 4? The probability of A prime union M prime is the probability of A prime plus probability of M prime minus probability of A prime intersection M prime. So A prime, it means no promotion, and M prime is female. So the probability of no is 876 divided by 1200. The probability of female or M prime in total we have 240 female divided by the number of managers is 1200. So is 240 divided by 1200, and the intersection of female and no promotion is female and no promotion. The intersection is 204. So the probability is 204 divided by 1200. So you can see, and the result is 0.76. You can see that these two probabilities are equal. Now look at this example. Now we want to obtain the conditional probability using a Venn diagram. It shows that the students that are studying a science subject, the Venn diagram shows those studying biology with B, chemistry with C, and what is the probability of a student studying biology if they are also studying chemistry. So if is given that, if conditional, you know about the conditional sentences in English, they start with if. So the probability of biology given that chemistry. So biology given that studying chemistry. So what is this probability? The probability of studying biology given that studying chemistry is the probability of intersection divided by the probability of C, the conditional part. So what is the meaning of this diagram? In this diagram we have 70 students that just study biology, 40 students just study chemistry. 30 students study both biology and chemistry, and 45 students who study and other science subjects. Other science subjects. So we have this. "45 biology, chemistry." So just biology, just biology, just chemistry, both and here other subjects. So in total we have 70 plus 30 plus 40 plus 45 students. It means 89. It's NS. So the probability of B intersection A, it means this area, B intersection C, is 30 divided by 89. And the probability of C is 30 plus 40. 30 plus 40 students are studying chemistry. So the result is 30 over 24. 27. Now look at this example. Compile a Venn diagram using marginal example. Managerial example. So we had this cross table before. Now we are going to plot a Venn diagram based on this table. Okay, so we had two events, A for promotion and M for male. So A for promotion and M for male. Okay. We start from intersection of yes and male. Intersection of yes and male is 288 divided by 1200. We can write the frequencies or we can write the probabilities. So here is A intersection B. So here is promotion. It's is A. A in total is 324 divided by 1200. We have already 288. So this part you can see that A is divided into male and female. Promotion is divided to male and females. So we already have these parts who are males. So here this part is females who got promotion. So here is 36 1200. Again, in male is divided into yes and no. It means promotion or no promotion. We already have 288 who got promotion, so we need 672 who didn't get promotion. So male is divided to two parts, and these parts, because this part is the intersection of male and promotion, so these parts got promotion, have got promotion, but this part no. So we need 672. What about this part? These parts are women who are not promoted. This part is outside of male and outside of promotion. So this area is females who are not promoted. Females who are not promoted are 204. So this part is 204 over, you can see we can obtain the values on a Venn diagram by using a cross table. And now we are going to obtain the probabilities based on this diagram. You can see A intersection M is this part. A intersection M prime, it means just A is this part. Just A is this part. Is A, it's A intersection M prime or A minus M. This part. A prime intersection M is just M. Is this part is 672 divided by 1200. So this part is just M, or A prime intersection M is M minus A, just M. And the probability of A is the summation of these two values. The probability of M is the summation of these two values. The probability of A prime is 1 minus the probability of A, and the probability of M prime is 1 minus the probability of M, and also you can obtain this result based on these equations.